Second part of this exercise is going to have us convert our iterative code into a recursive version, and that's going to be a preparation for the following exercise, which are going to be easier to express actually recursively than iteratively. So we want a generation function that's going to be executed by each child, okay, each process actually even of our tree, and this generation function takes as first parameter a generation number. So 0 for the parent, 1 for the first child, etc. And the value n that was selected by the user to start off with, which tells us pretty much how far we need to go. So let's iconify this window and go back to our code. We can modify what we have here to actually pretty much transform this loop and the loop only into a recursive approach. I'm going to rename this main iterative, okay, just so that I keep the old version. I'm going to cut and paste what I have right now. This is going to be my new main. So inside this new main, I'm still going to ask this information to start off with, but then immediately I'm going to call my function generation, indicate that I'm running with generation 0 right now, and pass the value n. The rest of the code will have to be modified to fit pretty much in that function generation. So let's go ahead and write this function here. The first parameter is the number of the child process, pretty much the number of the generation, let's call it gen. Second parameter is the value n. So let me open curly braces, and for now I just cut and paste in my code, okay, I didn't modify it yet. Now I'm going to take care of modifying it. First I remove this for loop, and I'm going to think at what I need to do for each iteration. First thing, test if I equal n. Well, that doesn't make any more sense now, we don't have a loop with an index I, but what I want to test is if my generation number is equal to n. So 0 is the parent, 1, 2, and 3 are going to be the children. Well, if the value n was 3, when I reach generation 3, child generation 3, which is pretty much generation 4 concretely, I'm going to stop, nothing to do, exit, success. Other than that, if I don't stop, I call fork. So I need here a variable int f. I can get rid of I can move f right here. Well, let's just add int here, int f equal fork, and then I go through my error handling. Okay, if something went wrong, error, forking problem, exit, exit failure, no problem, that doesn't change. If f equals 0, I am dealing with the child. I am generation something, and I'm ready to fork. So what am I going to do here after sleep 3? I'm not going to just go out of the if, because this time there is no loop, so I would just end my generation function. No, what I'm going to do is I'm going to call recursively generation. There is one more generation now, we are talking about the next generation, n is unchanged, and that recursive call is going to implement the iteration. If f is greater than 0, well, if f greater than 0, I am in the parent, I announce myself, I am generation blah blah blah, etc. I wait for my child that I just generated, and I will exit success when I'm done. Problem, am I going to ever return from this? Well, I could put an exit success here just to be careful, you know, to make sure that I never return from this generation function call when I'm a child. However, if you look at here, what's happening, look at it, what's happening, when you call yourself recursively, what's going to happen is that you either reach the bottom of your recursion, in which case you exit success, or you just keep calling yourself recursively, which is exactly what we want to do in that case, or you are in the parent, in which case you end up by exit success. So the code is pretty much, you know, self-contained and self-explanatory there. So let me save. We are going to first check for compilation error, syntactical problem, and then we are going to give a spin to this first version. So variable I undeclared, I forgot to remove it somewhere. Let's have a look. What line was that? Line 17. Line 17, indeed. We are talking with variable I here when we should be using parameter gen. This is happening again here, so let's fix those multiple occurrences while we're at it. Let's go back to Conqueror. That's a little better. Now, is it working? Let's give it a spin. a.out, same problem, n equal 3. It's taking a little bit of time. We have generation 0 here, it's 955. 955 is actually the parent process, so this is working good for so far. 955 generates 956, which is generation 1. Coming from 955, we are good. Generation 1, 956 generate 957, which is generation 2. Generation 2 generates 958, which is generation 3. And then here we have a little glitch. We display 0 when we should be displaying actually 958, sorry. Should be the one telling us nothing to do exiting. And then 957, 956, 955. Everything works except that 0 here that we didn't anticipate. So let's go back at the code and let's take a look. When gen equal n, nothing to do exiting. And I should specify here get PID. Let's save. Compile, run. The numbers are different, of course, but you can take just a quick look at it and you will see that this time we have the correct PID here that is displayed. So this was just omission of a parameter for the printf that was holding us back. And I think we are done with this recursive version here.